Welcome to my lecture videos. Today we are going to see about stability analysis in control system. What is meant by stable in a system? When you are going to take a graph, if you are taking x-axis as time, in the y-axis if you are going to take the system response, with respect to time, the response of a system, if it is going to 0, if it is touching to 0, when time increases, then you can say that kind of system is a stable system. When you are going to have the system response in a constant manner, then we can say it is a marginally stable system. When a system response is approaching infinite, when time approaches to infinite, so by that time we are calling as it's an unstable system. Before we are going to see about the Routh Hurwitz criterion, we are supposed to understand what is meant by zeros and what is meant by poles. When you are going to find a transfer function, so you will get one equation which will contain numerator and denominator. If you are going to find the roots of the numerator, what is the roots of the numerator? S plus 2, S plus 3. If you are going to take the roots of this numerator, S plus 2 into S plus 3 equal to 0. So, S is equal to minus 2, S is equal to minus 3. These are all the roots for the numerator. If you are going to take the denominator equation, S plus 6, S plus 5, S minus 2. So, when you are going to take, if you are going to equate to 0, then S is equal to minus 6, S is equal to minus 5, S is equal to plus 2 it will come. When you are going to consider this kind of transfer function, the roots of the numerator we are calling as zeros in control system. The roots of the denominator we are calling as poles. So, these poles will decide the stability of the system according to the Routh Hurwitz algorithm. So, that we are going to see. When you want to show these roots in a S-plane, S-plane means what? We are going to take real numbers in the x-axis and we are going to take imaginary numbers in y-axis, and imaginary number means I have taken as plus jw, plus 2jw, plus 3jw, minus jw, minus 2jw, minus 3jw, and so it will continue. So, when you are going to take the real axis in x-axis 1, 2, 3, 4, 5 real number, and minus 1, minus 2, minus 3. So, I have mentioned here. So, if you want to mention this minus 2, S is equal to minus 2 in the graph, see how I am going to do that. See here, this is equal to minus 2 and this is plus 2. So, S is equal to minus 2 here, S is equal to minus 3 here, S is equal to minus 6 here, S is equal to minus 5, S is equal to plus 2. So, all those things I am going to mark here, and this is the way of marking zeros and poles in the S-plane graph. Okay. So, what is meant by Routh Hurwitz algorithm? Routh Hurwitz algorithm, it will give how to find the stability of a system. So, who is Routh Hurwitz? Routh Hurwitz is control system scientist. They have provided one algorithm. Using this, you can find the stability of the system, or you can find the instability of the system, you can find marginally stable system, and not only the stability of the system, you can find the roots of the equation, characteristic equation. So, everything you can find easily using this Routh Hurwitz algorithm. So, this is what we are going to see today, and you see here once again I am explaining what is meant by stable of the system. A system is stable if the natural response approaches 0 as time approaches infinite. A system is unstable if the natural response approaches infinite as time approaches to infinite. A system is marginally stable if the natural response neither decays nor grows but remains constant or oscillate, means you can say it's a marginally stable system. You see here a transfer function, it is mentioned here, the general transfer function, and when you are going to find the general transfer function, and then after that if you are going to find the roots of the equation, see S minus Z1, S minus Z2, Z means it is zeros and P means its poles. So, zeros and poles it's given here. the roots of the numerator polynomial. You see here it is given roots of the denominator polynomial transfer function are called poles. The roots of the numerator polynomial of a transfer function are called zeros. Okay, fine. So now we are going to see one equation. You see here in stability of control system, easily you can find it out in one method. You can find it out whether stable or unstable. When you are going to find the roots, all of the roots are lying in the left half of the S-plane. So this is called a S-plane graph. Left half of the S-plane means you can say stable condition. The system is in stable condition. If the roots are lying in the right half of the S-plane, then you can say unstable condition. Sir, if you may ask the question, sir, one root is lying in the right half of the S-plane, then other roots are lying in the left half of the S-plane. So if we are going to tell like this, even one root is lying in the right half of the S-plane, then you can say the system is in unstable condition. So this is what we are going to see in the Routh Hurwitz algorithm. See here, stable system it is, see here the left half of the S-plane means it's all stable, and then right half of the S-plane means it's called unstable system. Okay, fine. So we are going to take one example to understand the Routh Hurwitz algorithm. Okay. So I am going to explain the Routh Hurwitz algorithm. I am going to take the characteristic equation of this. See here, there is a characteristic equation s power 4 plus 2s cube plus 3s square plus 4s plus 5 equal to 0. So this is what the given question. So how we are going to apply the Routh Hurwitz algorithm, and then after that how we are going to find the stability of the system, and also how we are going to tell the roots are in whether left half of the S-plane or right half of the S-plane, we are going to see. See, s power 4 plus 2s cube plus 3s square plus 4s plus 5 equal to 0. So if you are going to take one characteristic equation like this, the first you have to write vertically what is the maximum power of s power 4. So if it is the maximum power of s power 4 means you have to write immediately s power 4, s power 3, s power 2, s power 1 and s power 0. So in the descending order vertically I am going to write. And before that you have to check whether this is in order or not. You see there s power 4 is there, 2s cube is there, 3s square is there, 4s is there, plus 5 equal to 0. That means s power 4, s cube, s square, s power 1 and s power 0 all are there. If anything is not there, for example, s power 4 plus 2s cube plus 4s plus 5 equal to 0. Suppose this is the question, then by that time you have to include the square also by adding 0 s square. After that only you have to proceed your Routh Hurwitz array. So now it is crystal clear, all of the s from the power 4 to s power 0 it is here. So we can proceed easily this one. First we are going to write the coefficient of s power 4. So what is the coefficient of s power 4? 1 will be the coefficient of s power 4. Then after that, see, since this is the even number, then you have to jump in the even number coefficient. You see here s square coefficient is 3, and then after that again you have to jump from here to here, then s power 0 coefficient is 5. So you have to finish the first horizontal line using the coefficient of s power 4, using the coefficient of s power s square, using the coefficient of s power 0. So 1, 3, 5 I have filled the first horizontal line, and then after that s power 3. You see here the s power 3 coefficient is what, and then 2 will be the s cube coefficient, and then after that s coefficient equal to 4. So after that how I am going to continue this algorithm, you see. See, there are some formula and matrix rules behind this. So, I do not want to follow the easily I am going to tell how to solve this one using this Routh Hurwitz algorithm. You see here now the two horizontal lines are there. In the second horizontal line, what will be the first number you have to take? You see here the first number, the second horizontal line, the first number is 2. So, now you are going for the cross multiplication with the first row. So, you are going to multiply this 2 with 3 minus, you are going to multiply, you are going to start from the first row, first number, minus 1 into 4, divide by wherever you started. Where you started? From 2 you started. You see here how I am going to fill this here, the s power 2 column. Now I have started the second row, first number is the 2. I am going to do the cross multiplication. That means 2 multiplied with 3, and then after that minus 1 multiplied with 4, 1 multiplied with 4, divide by wherever you started. Where you started? You started from the second row, first number. So, you started here. So, this one it will come 6 minus 4 divided by 2, then you can say 2 divided by 2, 2 will cancel, 1 it will come. So, you are going to fill the number here as 1. And then after that the same procedure you are going to follow. The second row first number you are going to start, but you are not going to multiply with this number. I mean the second column first number I did in the previous step, but now I am going to multiply this 2 with 5, and I am going to multiply this 1 with 0. Why? Because if number is not there, then you consider as a 0. So, to fill this second number, I am going to multiply 2 multiplied with 5 minus 1 multiplied with 0, divide by wherever you started. Where you started? I started from 2, so the 2 I have to give. See, 2 multiplied with 5, it is 10, minus 0, divide by 2, then it will come as a 5. So, I am going to fill the number 5 here. You see here, s square, 1 and 5. It is there 1 and 5, it has come 1 and 5. Sir, now how to fill s power 1? So, see here, now you have to take latest 2 rows. Latest 2 rows means what? See, I am having first row, second row, third row. So, latest 2 row means third row and second row you take. So, third row and second row, the same algorithm we are going to apply. In these 2 rows, see the second row, first number you start, 1 multiplied with the same, you are going to multiply this 1 with 4. So, 1 multiplied with 4 minus 2 multiplied with 5, 2 multiplied with 5, divide by wherever you started. Where I started? 1. So, now it is coming as 4 minus 10 divided by 1. 4 minus 10, it will come as a minus 6. See, minus 6 is coming. So, I am going to fill this number here, minus 6. If I am going from here to here, everything 0 will come. 0 divided by 1, 0 will come. So, you need not to do that. So, if you want, you can do this one, 0 it will come. So, now again you have to apply the Routh Hurwitz algorithm. How can I apply? Now, you take the latest 2 rows. So, what is the latest 2 rows? Minus 6, 0, 1, 5. So, this is the latest 2 row. Why? The first row is there, second row is there, third row is there, fourth row. Fourth row latest, before the latest it is 1 and 5. So, these 2 rows I am going to take. The same algorithm I am going to repeat. See, in these 2 rows, the second row first number, it is of minus 6. I am going to multiply with 5. And then after that 1 multiplied with 0 divided by wherever I started. See, minus 6 multiplied with 5 minus 1 multiplied with 0 divided by minus 6 it is coming. So, minus 6 will cancel, then after that automatically it will come as 5, then you are going to fill here 5. So, now it is over. So, first Routh array we have set up. See, in this what I supposed to do to take some decision. See here, there is a first column, you have to take this first column. First column is what? First column number is 1. See here, this is the first column. First column number is 1, 2, 1, minus 6, 5. Is there any sign change? Yes. How many times sign changes are there? You see here, the 1 sign is positive. The 2 sign is positive. 1 sign is positive. But here the 6 sign is negative. So, positive to negative, there is a sign change. And again you see here the last number is 5. So, again negative to positive, there is a sign change. You see here, positive to negative it is coming, then again negative to positive it is coming. So, 2 times there is sign change. There is sign change. Sir, why I have to find the sign change? Sign change only will decide the stability of the system. If there is a sign change, then we can say it is an unstable system, you can conclude. If there is no sign change, you can conclude easily it is a stable system. If there is a sign change, you can conclude it is not a stable system, it is an unstable system. So, prediction number 1. Prediction number 1, I can find out the result. Since there is sign change 2 times, the system is unstable. The system is unstable. Sir, how many number of roots are there? I told already there is a graph. If the roots are lying in the left half of the S-plane, then you can say it is a stable region. If the roots are lying in the right half of the S-plane, then you can say it is an unstable region. Unstable region. Sir, how many number of roots are there in the right side? How many number of roots are there in the left side? You can easily find it out. How many times sign changes it happen in the first column of the Routh array? Then you can say these two roots. These 2 roots are lying in the right half of the S-planes. Why? Because 2 times there is a sign change. Definitely there will be a 2 roots will be in the right half of S-plane, right half of S-plane. The remaining root S-plane, the remaining root. How many remaining roots are there? How can I find the total number of roots? See, the characteristic equation started with s power 4. The maximum power is s power 4. So, s power 4 if it is there, normally 4 roots will be there. 4 roots will be there. So, 2 roots will be in the right half of the S-plane means the remaining roots. Remaining roots, how many roots? 4 minus 2, the 2 roots. Remaining 2 roots will be in left half of S-plane. Left half of S-plane. So, this is the way of prediction of stability using Routh Hurwitz algorithm, and this is the fundamental problem. So, there is no zeros here, and there is no any complexity here, and this is one fundamental problem we have seen. In the next video we will see with another example.